Little rundown on servos. So I'm still developing a servo test rig. So this thing, this little video here is just a first impression, just to get an idea of how these servos look like, of how these servos are built, and what the general quality impression of these is. I cannot quantify any of the data they published in the spec sheets, meaning speed, regarding torque, regarding precision, regarding everything else around. But I'll be eventually in the position to do that when the test rig is ready. I'll have a Hall sensor on it, so I can test positioning. I'll have a current sensor on it, so I can see how much current the servos draw. I'll have a little CPU on it to count speed, etc. So and I'll be able to do like an infinite cycle, an infinite amount of duty cycles on the servos. So I will have, once this is ready, a pretty good impression of how those servos I test develop gear slop over time, or will get sloppy with positioning, etc. So let's dive into it. I will mainly focus on digital servos. And I will, for this video, focus on the 9-gram class, or the 12mm class, as you might call it, or the micro class. There are countless names for it. All these servos are 12mm thick. So they are commonly used, sorry for my French, commonly used on the foam planes we fly. For this first impression, I'll just have this trusty old crossfire receiver with PWM output hooked to an old Fly Color 30 amp ESC, and I'll use the BEC for powering on an old 4S F-Tech Diamond LiPo, these good old trusty LiPos. I'll have to admit that this is far from ideal, as the output signal of the crossfire receiver is optimized for analog servos, and digital servos will if we hook them up like this, cause a little electrical noise, or be a little affected by electrical noise. So we certainly won't hear the full potential of them. Another thing to consider is why do I focus on analog servos here, on digital servos here? Is the fact that regarding the application, regarding flying with a flight controller for FPV planes, etc., the flight controller needs a precise servo, as precise as possible, to avoid overcompensation and therefore dolphining on the pitch axle, etc. So digital servos, most digital servos, are just analog servos in disguise. They still have a potentiometer for measuring the positioning. I'll show that later when I open a servo. But the signal processing is done digital, so it's not relying on resistors, etc. So the positioning of digital servos, and here is the main USP, is a lot better on flight controllers than it is with analog servos. Okay, for this first run-up, I'll just first, after 5 minutes of waffling, we'll introduce the servos. This is the KST DS215MG in the version 3.0. It's a digital servo I'll use for reference. It's pretty much one of the best servos you can get for 35 euros. This is the reference servo. It's almost the fastest you can get. It has it does 60 degrees in 0.05 seconds, and it's reasonably strong together with that. This is the reference. Then I'll just give you, for comparison, a Tower Pro MG90S. This is an analog servo. Why do I do this? Just to give you an impression how differently these sound. Then give you a short rundown on the GDW DS021MG, which is a pretty brilliant digital servo I found recently. I'll give you an impression of the VOTIK 9495MGD, which is a 2S LiPo, which is already 2S LiPo ready servo, which is already programmable, although we'll have a little limitation to that, but let's see that later. And this PTK, aka VOTIK 7452MGD, also 2S LiPo, little servo in the same, or almost the same body as the GWs. And on the top of the line, on the top of the range, the D-Power Rex 265SG, which is a 50 euro servo, but to be honest, this is the best servo I have to find yet. This is the best servo I have seen so far. Okay, let's dive into it. For the first idea, I just wanted to give you an impression how these servos sound. The servo sound itself is a pretty silent, so it's pretty hard to reproduce this on video. But the table you see here is actually hollow, so it's a pretty good resonance body for you. So we might get a pretty good impression of how these servos sound. So let's just start with the KST DS215MG. Pretty silent. So I'll get the Rex for comparison. Okay, from the first impression, what we can hear is the Rex servo is super smooth. Okay, you can expect that from a $50 servo, but pretty smooth. And the 35 euro KST, which is normally my go-to servo, is a lot louder. Okay, let's hear the VOTIK for comparison. I think you can already hear a little electronic jitter. Although the gears seem to run pretty smooth. We have a lot more of digital noise sound in it. Nothing bad, but it's there. Although that VOTIK servo for me looks like a straight up copy of the KST. I'll compare those directly in a moment. The servo body looks exactly the same. Now we have the PTK. Oh my god. Can you hear that? It even makes different sounds in different directions. That's funny. I bought these for my Easy Star. Okay, and let's see the GDW. Louder. But no noise, absolutely no noise. Super precise. Yeah. Pretty good. And now the analog Tower Pro MG90 for direct comparison. Okay, the first thing you hear is this. Nice. So no input at all. This is a new servo, by the way. Okay. I don't think I have to comment that. Yeah. So far, first impression, the Rex, brilliant. Very good, the GDW. Okay, the VOTIK, or pretty okay, the VOTIK. On par, I think, with the KST. Let's hear them in direct comparison. And yeah. And on the bottom end, these PTKs, well, yeah, maybe they hold up in the endurance test later on. Okay, this is the VOTIK. Okay, for a really good idea, I'll have to run them from a flight controller with a digital signal at around 330 hertz, so that we can eliminate this electrical noise. But although these two servos look identical, the KST has more silent gears than the VOTIK, but let's be honest, you won't hear that in the air, won't you? So, okay, that's for the first impression. I'll just open these up and give you a good impression of how these things look from the inside. Bear with me. So I opened up the KST first. Just a few specs of this. it is available at around 35 euro. It's high voltage capable, up to 8.4 volts, but I only found specs up to 7.4, and it does 3.7 kilograms of torque at a speed of 0.05 seconds. It's around 20 grams. It has 2 ball bearings, a coreless motor, and hardened metal gears, whatever that is. I suppose it's steel gears, but I'm not quite sure because the color of the gears is, I hope you can see this, the color of the gears is different from gear to gear, so I don't know. First of all, these are really, really well built. The body looks super precise. If you look at the bushings where the actual rods that hold the gears are suspended in, are really, really well made and precise. And if you just look at this, you'll see the gear rods are absolutely parallel, even without the support of the top deck. If I now turn these around, you'll see the quality of this. It is probably a really good potentiometer because these servos are known to be super precise. The soldering job is actually absolutely flawless. I don't see any problems with that here, and the contact points are also covered with conformal coating, whatever that is. It looks like white plastic dip, I don't know, but these are really, really well made. I don't think you can actually see it, but just look at these 2 soldering joints here. Absolutely precise. So yeah, very well impression just from opening the servo. The second ball bearing is actually located here, directly above. You can see this directly above the potentiometer. Yeah, my reference servo, pretty good. And now the VOTIK servos that I suspect to be a direct copy of the KSTs. These are also very well built from the outside. The body looks exactly the same, with just one difference. Where the KST body has, in German we say Phase, has this the edges rounded. These are just directly out of the press or out of the CNC machine. They have no gear slop at all. All these servos, except the analog servos I have here, in this comparison, have 0 gear slop, but with one exception, and that is the PTK servo here, and I'll come to that later on. So I'll just open this one up. So I opened the VOTIKs up, and I'm actually a little surprised because what you can see here, the stickers they put on the servo sides actually cover a cutout. And what you now can see here is that it is almost the same. No, it is the same size of motor than we just saw on the KST 215. And here you see the difference in manufacturing. The soldering looks pretty good also. I think the soldering looks pretty good also. But it is not the same perfection as we just saw on the KST version. And it is a different FET we see here. And yeah, well, the price difference from €20 to €35 the KST costs is now seen here in the manufacturing and in the parts. €20 is not fair actually, because I got this on sale for 16, which is, regarding this servo, a pretty good price. I'm pretty sure that we have a different potentiometer here inside, because the bottom looks completely different. And these are actually advertised to be programmable. So I wonder what specs or details you can program on these servos. I didn't find the programming suit yet, but I have found a programming card for PTK, which is, as far as I have done my research, the same brand as VOTIK. But let's see, I'll have to verify that. The biggest difference I see here is actually the gearing. As we just saw on the KST, the gearing was hardened metal, and this gear here, this gear set here, is brass on the sides and probably aluminum here on the side. So these servos are pretty comparable, but I am far from saying they are the same. Specs look really okay though. There were two different similar servos of this. This one is the faster one. There is also a stronger one. This 9495 does 4.8 kilograms on 7.4 volts. It is 0.06 seconds for 60 degrees. It has a deadband between 1.4 and 1.6 microseconds. It is a cordless motor. It has 2 ball bearings and weighs around 20 grams. Regarding the fact that you can actually buy a spare gear set for the KST, and the form factor seems to be identical, I wonder if you just go with these servos, and when they develop their gear slop, inevitably, because brass is of course not that hard as hardened metal, you can just swap the gears out and still have a good servo. Okay, let's have a look at the others. Okay, let's go on with the PTK 7452MGD. When I ordered these, they were called VOTIK 7452MGD, which leads me to the suspicion that PTK and VOTIK is actually the same brand. And the PTK programming card for servos might actually work with the VOTIK servo I was just reviewing. So I'll give that a shot, and I alter that one, and let's see if it's the same. What's interesting about these is this is a single ball bearing servo, and if you look closely, you can see we have a little slop here in the servo arm, which is not that bad, but as we have a plastic body here and all the bushings are all the rods are suspended in plastic, we might develop considerable amount of slop later on. as you won't use probably a servo frame with counter bearings, like, just bear with me for a second, like these, where you can put your servo in. This is for wings, for glider wings, where you put your servo in and a ball bearing exactly on opposite of the servo, which takes all the asymmetrical load off the servo. The frame, as you can see, a pair of frames is actually $20, including the hardware and the ball bearings. You won't do this probably for a €7 servo. I got these for €7 on Banggood, and yeah, I'll just give them a shot for my Easy Star project, as they are pretty light and only weigh 13 grams. The specs seem okay. It is on 6 volts, capable of delivering 2.3 kilograms of torque and 0.1 seconds of speed for 60 degrees. It has 1 ball bearing, and they advertise it with a dead band of 1 microseconds. Well, let's see. The difference, another difference actually is the servo arms and the width of the servo arms. These are considerably smaller than the other ones I was reviewing. It is actually, I think, a 20-tooth interface. Well, let's see how they look from the inside. So I have these opened up, and to be honest, I'm not impressed. As I said, we have considerable amount of slop, which is because we have just 1 ball bearing. The ball bearing is on top of the main gear here, and we have actually no ball bearing here on the rod above the potentiometer. So actually your potentiometer is the second point where this main rod with all the main load is suspended. And if you look closely, I can just move this. So these won't last long, I'm pretty sure. We have aluminium gears, and a brass pinion, and we have rather sketchy soldering on the bottom. If you look closely, these are not very pretty. If you can, hopefully you can see this here. They are, on the other hand, also rated, or yeah, they are also advertised as programmable and 2S LiPo ready. Yeah, I'd use them for a scratch build. I'm not sure if I use them for the Easy Star, because it's not a that cheap build. I want to risk with sketchy servos. Let's see how these turn out. I'll get one of these on the test rig once it's ready, and if these hold up and are just allowed as we have seen before, then I'll use them. But I think I will open up every single one I want to install into the Easy Star, because the soldering looks pretty sketchy. Okay, yeah, and now the last one. Yeah, now the GDW. It's a, well, €7 servo. I purchased these for my Frankendart project, These I have had very good experience with GDW servos on various glider projects because they make pretty good full metal wing type servos that are actually a lot faster than the KST X10, and I was pretty impressed with them, so I gave these a shot. And I'm also pretty impressed with these because they have a very good quality impression from the outside and how they sound. Absolutely no gear slop, 2 ball bearings, 6 volts, 0.11 seconds for 60 degrees at 2.7 kilograms of torque. They are advertised as with a deadband of 3 microseconds and weigh, sorry for that, weigh 13 grams. I'll just open it up. So I opened these up. The soldering on these actually looks pretty decent. We have absolutely nice, precise drops here. All the equipment is just wrapped in some adhesive tape, but as long as you don't see it, I don't care. The gears are actually aluminum and with a brass pinion at the motor. I actually lied to you because it's not double ball bearings. They are advertised as double ball bearings, but actually they are not. They have a pretty nifty solution, low-cost solution. They have some kind of bushing or frame above the potentiometer that holds the main shaft. So the potentiometer is not the other point for the main shaft. It's actually suspended here directly in the servo body. So regarding the sound they make, regarding the precision and the zero slop, I experienced with these right now. I find this is a pretty good budget servo at €7. And I also lied to you a second time. The VOTIK, aka PTK, are not €7, they are €5. So, well, these GDW are actually discontinued. They have an upgraded version that is called DS021MG, but the specs are comparable, and I hadn't had these at hand, so I'll just took a look at these. But these, as I said, I have never had a bad servo from GDW. So if you are interested in a good budget digital servo that is only 13 grams or 12 to 13 grams, you might give these a shot. And now the servo you all were waiting for. This is the Rex 265SG from D-Power, or I will call them D-Rex from now on. These are the only servos in this comparison that are actually not made in China. These are made in Taiwan. If you if you like that, you might give these a shot. These are pretty well built. From the first impression, they look a lot more refined than anything I had on the bench here. From the size, from the specs wise,
The outside size is exactly, the form factor is exactly the same as the DS215MG from KST. So if you need any additional hardware or like servo frames with counter bearings, arms, etc., just Google for equipment available for the DS215, and it will work with these also. These are pretty expensive servos if you compare them with the others. One of these cost 50 euros, but bear with me, I think they're worth every penny. They are high voltage capable up to 8.4 volts. Voltage is your friend, as you know, and on 7.4 volts, they actually deliver 5.8 kilograms of torque, which is brilliant for such a small thing. They deliver 6.5 on 8.4 volts. They are also pretty fast at 0.065 at 7.4 volts and 0.06 at 8.4 volts, and weigh 18 grams. They have 2 ball bearings, a cordless motor, steel gears. These are true steel gears. At least they advertise them like that. Absolutely no slop. Rock solid, and as you remember from the initial comparison on sound, these are super silent, and therefore the gears themselves must be pretty well made. So let's open these up. So on these I'm actually a little surprised regarding the fact that these were super silent. I expected the gears to be at least a little greased, but I don't see any grease, and I don't really know why, but maybe it's some kind of Teflon or something grease that it's just some dry grease, which I cannot see directly here, but yeah, it's no visible greasing inside these. It's double ball bearing. Look at this beefy shaft. The ball bearing for the top is actually inside here, so in case you missed it. And look how beefy this main shaft is, which is then suspended in the body here, of course. And the potentiometer that is responsible for positioning is actually not soldered in via cables or so. They just had this 3 DuPont pins with pretty neat soldering. Probably this is the best soldering I've seen so far on the servos I opened. Also on this side, but I cannot really judge the difference in the signal calculations between those, but these also look pretty good. This thing is soldered absolutely flawlessly. So yeah, what can I say? Why would you spend 50 euros on a servo like this? Well, if you consider the amount of money you put into an airframe, let's take a mini truck. The mini truck these servos will go into. I have 2 of them. These will be the servos for my mini truck project. And just have a look at the mini truck. You now pay around $300 US for a mini truck. This is just the airframe. Then you put a a flight controller in it, you put a GPS in it, you put all your hardware in it, you probably run Crossfire, Diversity, you probably run an APD or some other beefy ESC in it. You will probably run a KO motor in it, which is in itself something like 100 or to 130 US dollars. And the amount of money you just put in this in this airframe, not counting a GoPro or the other stuff, is pretty much. And if you consider the fact that a good servo makes the plane actually fly a lot better because the positioning is better, the torque curve actually is better. You can do better hinging, you can do better linkages with stronger servos. The return on investment on good servos is actually pretty good. I don't say you have to spend 50, but the KST we looked at before are pretty good bang for the buck. Yeah, that's about it. I would like to do this again once the servo test rig is ready. And then I'll give all of these servos and a few others a quick shakedown with 5,000 or 10,000, depending on how long it takes, duty cycles, and then measure their precision again, measure their torque, measure their torque under load. All these, no, the speed under load, I'm sorry. All these speed numbers I told you are, of course, without load. And if you consider, let's say, 50% of the possible load, the possible torque you can get out of these, and then compare the numbers, you have the numbers that are important in real life. And I'll test that on the rig, and then I'll give you an impression how this went. And maybe we'll start some kind of servo nerd review series on this. Okay, thank you for watching. This was a pretty long video with a lot of waffling in it. But if you're actually interested in servos, this might have been helpful for you. Okay, and best servo, complete budget side, I would say is this one, the GDW. You can't go wrong with these. I wouldn't recommend the PTKs. If I hadn't had already ordered these, a pack of 6, I just wouldn't order these again. One ball bearing is just not enough. If you want a pretty good average servo, then the KST is the servo you should go for. As you see, as you have seen when I opened them, and as soon as they develop gear slop, which might be an issue, you can with wear or something, you can order a new gear set for them, and you can freshen them up. If you are not interested in spending $35, these seem to be pretty good. They're almost the same, as I said, as the KST, except a different board and a different type of gear, but they seem to be pretty solid. And these are, well, these are not top-notch, but they are pretty close to top-notch. If you want to buy top-notch servos, you could go Yeti or GWS and easily spend $100 or more on servos from this size. But this is pretty close to perfect. Yeah. Okay. Thanks for watching. That's it.